although there are various ways in which you can optimize the battery for different customer use cases, there are a few key inputs that are standardized for each design. Namely, that would be the electrical specs for the battery, which we are going to find here within the control zone. In the design and hardware section of your account, you can click into the edit pencil for any battery to take a look at the specs and how we use these numbers to inform the battery modeling. So a few key metrics to point out would be the lifetime capacity, and we would assume 1 cycle a day to derive this number. The depth of discharge, the max charge or discharge power rating, the end of life capacity, in which we will assume degradation of the battery to reach this value at the end of the lifetime, and then the total capacity of the battery. We will also calculate usable capacity, which is total energy capacity times the depth of discharge. And then we will also take into account the round trip efficiency for those calculations. Now let's go take a look at a design and see how you can change the settings for different use cases for your customers. So within the design toolbar, you can add your battery for the battery section. You'll also be able to notice that we've added a few key metrics to help you understand different backup requirements and the value of your battery under certain scenarios for whole site backup and peak demand reduction. You can also notice the ability to switch between AC connected and DC connected for your battery solution. In the DC connected solution, you will be able to appreciate higher round trip efficiencies and also oversize your PV system because of inverter limitations that would otherwise limit power output in an AC connected solution. We also have battery control schemes that are available for you to utilize. The default selection will be self-consumption. This is generally going to be the most popular one and most favored for many use cases. This is essentially a battery control scheme that will be load following. So PV system will meet the customer load first, and then any excess generation will be charged to your battery. Discharging of the battery will happen after PV generation drops off and the load exceeds that generation as well. The other battery control schemes that you can utilize are below this selection point. So minimize grid import cost will essentially optimize for time of use rates. It's really key for those markets where you want to charge when you, again, have excess generation and discharge during peak pricing hours. So this is a bit more optimized for those time of use rates. The last or third to last selection point here is maximize savings. This is really great for California markets where you will optimize for time of use rates and also be able to take advantage of hours of the day where export credits are greater than the charge for electricity, or rather the price for electricity imported. So in those scenarios where battery arbitrage makes sense, you will actually discharge your battery to the grid versus meeting the load. And that will often be a better choice for you in certain markets like California, where you do have lucrative export credit hours, and this is the selection for you. And then last but not least, there is peak demand shaving, which would optimize for reducing your peak demand. And you'll also notice that you can create custom battery control schemes for other specific use cases that you might have. And lastly, there are a couple of fields where you can enter a value for either the percentage of the load that is offset or a kilowatt value in case it's a portion of the load. So in certain situations where perhaps it's a three-phase power system and you're using the battery to back up a single phase, you can enter values here to limit the amount of load that is offset by the battery. Now, moving over to the proposal, there is often a need to explain how a battery works to the customer through charts and graphs and better visuals than what you might have on your default template. So if you navigate over to your template via the Customize Proposal sidebar, you can edit your template directly here. And the couple updates that folks like are the daily energy flows, and self-consumption and export limit breakdown. So if you toggle these on into your template, you'll notice them appear under the system performance graph, where you can see self-consumption and export to grid. And then you can also click into the daily energy profile. This will open up a similar chart that we saw in the design toolbar, where the load profile of the customer is on the page. We can see the times a day where the battery is being charged, discharged to the load, and any excess generation from the solar system that is exported to the grid. And you can understand this and explain it to your customer under various seasonal scenarios. And if you do have interval data inputted or more specific load profiles for a weekday versus the weekend from the energy section, you can take advantage, or you can make note of those differences under those different time scenarios. So again, another great chart to highlight battery modeling at work. You could turn on those daily energy flows and the self-consumption and export to grid values as well. Hopefully this video was informative, and please reach out to us should you have any questions about battery modeling in OpenSolar.
OpenSolar,